To discuss with you about the irrigation and the water management in protected cultivation structures. So that is, for example, you have polyhouses, greenhouses, and all those things, and you know that we are not allowing any external rainfall or any water. Rainfall to to come inside these structures. So ultimately we have to go for irrigation, and what we mean by irrigation exactly is the application of water artificially, or you can say to meet the requirement of the crop, or you meet the requirement of plants, or you can say the requirement of fields. You need water, and to meet that water, if it is not happening naturally, uh, you have to give the artificial application, and the artificial application is called irrigation. Now there are different ways to irrigate, and most probably from the time the man has started cultivating the fields from the maybe near rivers and water sources, he must have started irrigating the crops. So now, considering that thing, I'm just interested, before going to my topic on irrigation of protected cultivations, I'm just interested to make you understand the concepts in a very simple terms. So let me come up. Can you tell me what is this picture is? This is a picture of, you can say, is a flood irrigated, or you can say a totally flooded water. Yes, it's a totally field which has been flooded. Uh, Let me have the these things, so that field which is irrigated, so and it is flooded. So what I want to come up, like just to make you understand that this is a wrong way to irrigate. I mean, this is simply, you are wasting water, you are wasting energy, you are wasting time and all, and you are just disturbing the soil structure as such. So this is one of the ways, and it is normally practice. Still, people are doing it, but the wrong practice. There is one way, other way to irrigate in this farm by furrows, where lots of water is there. You can just see in this picture that lots of water has accumulated in the fields, and lots of pumping has been in process. So it's maybe the pump is running for hours together, and it is just electricity wastage, and the water you are just taking, the water is coming up, it is flooding, and then it is going down, seepage, runoff, infiltration, and all kind of water, you know going, and ultimately uh, you will come up with the field, maybe saying that the field is irrigated. The other way to irrigate is with the help of such pipes, the pipes which are close to the plants, and the simply water is coming in a very small fashion. This is called the drip irrigation, and we will be discussing these things in detail in this particular topic. Now, this is a very interesting picture, and I just my whole this presentation most probably be dependent on this particular picture. Now, what is happening? I mean, just take this picture and try to understand what the picture I have shown you in the first one, when you have flooded the field with irrigation water, and you just totally water is stagnated on the field. Now, this is the situation where lots of water is surplus water. There is which is beyond the capacity of soil to bear, and that is all the soil's micro and macro pores. Whatever the air was there inside, whatever the structure was there in the soil, this is all being filled up with water, and now there is no more water can hold inside. So the water is now on the top of the soil, and this situation is saturation, and that's why it is written there, it is a saturation level, and this level, the totally water is there, and the water which is present in the soil is gravitational water. So this is the water which is of no use as such. So that's why I was saying to you that this is totally wastage of water. What is happening is there that this water, when you put, you're just pumping out the water from the ground, and then you're taking a time, or waiting idly to get this water disappear, so that it may go in runoff, it may go in leaching, it may go in infiltration and all. And then your main thing and the main condition, which is the place when technically your macro pores water goes, and then you have only the air comes in these macro pores, but the micro pores has water. And this is the ideal situation, which is called the field capacity. Now, this is the capacity, or this is the position, or you can say the this when you consider the soils as good for cultivation, and you want this kind of situation for whole of the plant cycle. If you have this kind of situation in the field, you will be having crops growing healthy, and they will be having neither surplus water nor less water. They will be never thirsty. They will be having adequate water. You can take it as a very simple example, like me or you or as any human being or animal can't drink maybe 10 glasses water at one place, or maybe 5 liter of water in one go, and then wait for and will not get water for next 1 week. It will not happen. We need it at frequent intervals and to meet our body's water requirements. Similarly, if the soil needs this thing, if the water is given to the soil in proper intervals and its situation remains in field capacity, the soils may not need extra water for that. And this is the position where we say the available water, and this is the water which are interested in. Now, drip irrigation has a role in this, because if you are irrigating a field and you are just making the field capacity and just keeping the field capacity by irrigating frequently at small intervals, then your soil will always be healthy and your soil will always be working, and plants roots will not suffer and they will also be working. You will be having more photosynthesis, more working sourcing, and there is more yield, more quality, and all that things. Now, beyond this level, again the water goes to permanent wilting point, which is beyond that the water is not available. Now, in flooded systems, you will be having this situation in a cyclic form. For example, you are irrigating today, then you are waiting for next 5 days to wait for the extra water to go. Then you will be having the next 5 days, most probably the available water. I'm just taking the hypothetically, and then again you will be having again not available water for next 5 days, and again after 15 days you are repeating irrigation, for example. Then again and again you are doing it, and ultimately you are coming up for only 5 effective days per cycle. So if you are doing it in a proper drip system, it will be for whole 15 days you will be in the field capacity. Now, going ahead, this may be the cycle of moisture in conventional and as well as in the drip system. The blue line is showing the peaks. You can see more saturation, then totally down, then totally up, then again down, like a zigzag. But in drip irrigation, you have very frequent irrigation and a smooth and uniform graph. The field capacity, I'm just again and again was repeating this word. This is the percentage of water remaining in the soil 2 or 3 days after the soil has been saturated and free drainage has been practically ceased. Technically, you can just see it here that in saturation, all the micro and macro pores being filled with water, and then in field capacity is available. The water is available only in the micro pores, and in the wilting there is no water. So this is beyond permanent wilting points. The wetting patterns in different soil types is like this. So there is, whenever you just, if your drop is coming in the soil, it may percolate to more depth in a sandy soil, but it may not percolate down in clay soil, and it may be having the surface spread. So this is all. which is background of drip irrigation. So with this background, we will be taking up the drip irrigation things, and let us move ahead. Now, this will be the drip irrigation is the concepts, then the components of drip irrigation systems. That parts which you can say the equipment, how this is designed, how it is made, and how we go for this, and then of course something on the maintenance also, how these things are maintained, because they need servicing time to time. Then fatigue, sorry, the fertigation equipments which are needed, um, and then the fogging and misting systems, which is, as I told you, that there is a fogging and misting systems were also introduced there in the protected cultivation, and has a very important role. So irrigation, as I've discussed already, is artificial application, and the goal is to water supply to the root zones, then design according to crop consumptions, then irrigation at proper time and in the suitable quantity. Normally, when we calculate that the crop water requirements, or you can say how much water is required. So this is all not endless, not unlimited, but in drip irrigation, we always go for very calculated amount of water only as per the need. This is called the demand based, you can say, or only as the plants need, only that much of water is added to the soils. And these the factors which have been influencing this application or requirement of water is your pan evaporation factor, that is the pan, you can say, or ET factor, it is called. Then there is a crop factor, the type of crop, and according to there is a crop factor. These are all tables, and they are available, and you can just see and select the area. You will have the ET of that area, you will be having crop factor for each crop. And then canopy factor is how that crop is having canopy. The canopy, I hope you all know that this is the coverage, or so the shade effect of the tree or a plant on the ground, and on the basis of that, the canopy factor, the ET depends. The transpirational losses or evaporation losses are more from the naked soils as compared to the covered crops. So this is on that basis the factors are there. They are also available in the form of table, just like your periodic tables and all. So then there is a crop area in square meters is E, and on the basis of this there is a calculation, and you come up for the water requirement for the crop. This is the same slide which I was just taking. So it is the application of small amount of waters near the root zone. So if you say that what is this? What is the drip irrigation? Is a can say less evaporation losses as compared to traditional irrigation methods, no interference with cultural practices, less disease and pest problem. Then irrigation application rate can be adjusted as per the soil type, and then less energy consumption. So naturally you are running the pumps at maybe earlier you were running for flood for 7 hours or 8 hours, but I think then drip irrigation it is just taking up for 1 hour or maybe half an hour, and as such there is less saving, lots of saving of groundwater as well as the electricity. The typical pictures just depicting your ways of irrigation. On the top, this is in the field conditions, in the orchard conditions, and below there is of your interest, that is drip irrigation in greenhouses. So you can just see the bed, see the drip lines there, and how these are irrigating the plots. Now, effective root depth in different clay, loam, and sandy soils, you can see the wetting pattern. This is called the wetting pattern. So, there is a soil from which around 80% of water is utilized by plants is absorbed. whereas it is not possible, or you can say in the normal irrigation, or you can say the flood irrigation. This was the first component, and the second is about the different parts of a drip system. So, normally, a drip irrigation, as you know, that it is a network of piping. So there is a big pipe, then which is taking the water, just like you can just take it as a very simple the public health water or potable water, which is coming to your house in the form of tap. There is a big tank somewhere from where a big pipe is coming to your town or village, and then from that big pipe there are certain sub pipes, or smaller size pipes which are coming to the your area, and from that a small half-inch pipe is taken up and it is coming to each household. Now similarly, your drip irrigation is also has bigger pipes which are coming from the water source well, and then it is coming to sublines. So then it is coming to thin lines and then to each dripper. So this is the like filter, and the above all, just like your potable water is treated, the irrigation water in drip system is also filtered. There are lots of impurities, so and it is very important that the irrigation water or the drip irrigation, the water source, the water which is you are going to use in drip system, it has to be cleaned, it has to be totally cleaned and make free from impurities. And because these systems always clog the irrigation, and once the irrigation system is clogged, it will be a failure of the system. So you can say the filtration, or you can say the filter unit is just like the you can say the heart of this is like it's like a heart of uh, heart of you can say the drip system, students. So now some other components are there which we'll be discussing, like bypass assembly, what is non-return valve, fertilizer tank, pressure gauge, control valve, air release valve, flush valve, different type of valves which have been installed at different places. This is a typical you can say a network, or you can say typical network of drip system, which I will be showing you in the form of an animation, and this will be more clearer to you. Now I'm coming to the filtrations first. So this is a typical filter, or you can say a gravel filter, or sometimes it is. Now you just try to understand all this very carefully, these things, because these are very interesting to know. Now what is happening is, for example, the water which is coming from a well, or which is coming from any other source, maybe a pond, maybe a pump or whatever, that water has some some the water is coming in some quantity which is on the basis of the discharge of that pump or centrifuge which is being installed there. Now the water as per requirement is in give to this filter, and the rest is shifted back again to the well or the water source by bypass assembly. So which is there, the bypass, the water is going bypass back, but and as per requirement it is going in this tank. Now, what is happening in this particular kind of filter? This filter helps in removing the impurities like organic matter, or algae, filaments, and maybe some this kind of material, twigs or leaves, and like that. If there is any that kind of impurities in the water, that is being removed here. This is another type of filter, another the same filter. I mean, the shape is different. Then you have another type of filter which is called the screen filter. So this is a filter which is normally installed after the sand filter or the media filter or gravel filter. The name is same. Then the water which is come clean from there, it is fed to this, and very minute holes in this. They help in removing further the impurities. This is the disk filters. This is another part of screen filters. So this is another type, just to remember that these are different types of filters. And then one more important type of filter is called the hydrocyclonic filter. I mean, these filters are uh, installed where normally you have a water from bore or from well. If you have a water from some shallow source, you can skip this kind of filter. There may not be use of this filter, but yes, in case of filters which has sand impurities, these kind of filters are really needed, because they act on the centrifuge and they settle down all this kind of impurities of sand, silt, and particles, and it's removed and water is clean from there. Now, after these all filters, your real work starts at the networking of piping. So normally we use the PVC pipes for main and sub mains, which is the main, bigger size pipes, and they are just buried around 2 feet down in the ground. So in case of poly houses also, these pipes are buried down near the bed, or maybe at the in the you can say the corridor areas. And then in the end of each these pipes, there is a flush valve which is normally installed and time to time open to clean these pipes. So this is the networking is done with the help of these kind of pipes. And then there is one more. Type of pipes which is called laterals. Now this is the pipes on which your drippers are fixed. If they are fixed on the top, they are called the online drippers. If they are already inbuilt, there are sometimes these drippers are inbuilt at the time of factory. They are inside, fitted inside. Just you can just see in this picture, there is a dripper which is inside the pipe. It is not visible like this, as they have just shown it in the form to you, but it is inside the pipe. Only the whole sink is visible from outside, and that you can order it on the basis of your water requirement, and accordingly you can install that. So the different type of filters which we is going to, sorry, the different type of drippers, or you can say the ammeters, which we are going to use on these laterals, they depend on the water requirement, as we have calculated that how much water. For example, you are calculating and you have come up with that, yes, your plant needs 20 liters water per day, or maybe 20 liters water is at weekly interval, and like that. So, and there is a dripper which is having a capacity to release water maybe 8 lph, or maybe say 8 liters per hour. So you know that you have to open that dripper for 2 hours, and just to after 2 hours you will be reaching around 60 liters water lph, or 16 lph, and then you could just close down the system, as you have quantified water which is being all added to the soil. These are typical drippers. This is the typical, you can say, the types of drippers which are normally used, and they are online. You can just see how these are fixed, and they, when the water is passing from that, they are just slowing down, because this water comes in these pipes under pressure, and then these drippers has a main role to slow down the water speed, and to if still if there is a chance that any impurity comes to this level, it has to be removed, and then it is drop by drop. The drippers, they are just that's why their name is dripper, because they are just dropping the water near the root zones of the plants. So normally this is a typical type of dripper, which is taking the uniform spread, maybe a hill or maybe the ground surface is undulated, it is not affecting. So it is normally used in greenhouses also, because from the first dripper to last dripper, the water is supplied at a uniform amount, and these are inline drippers which are present inside the drip lines. Now, I'm just doing it just to make you understand these all concepts. So then there is a walls, the different type of walls which are used in a installation of a drip irrigation system. Now, what I am discussing with you is a drip irrigation working, drip irrigation walls and all that. These can be, the drip irrigation is very much in practice in open fields also, but normally in open field it is not conditional. But of course in poly houses you can't do it, run a poly house without drip irrigation. So in poly houses it is a basic requirement and it has to be there to irrigate. But in open fields, yes, now the for furrow irrigation, or you can say the total irrigation is now getting gradually replaced with this kind of drip irrigation and pipe outlines and all that. For I have videos, I've selected some videos also. I will show them once I will come up with the presentation. Now next is everything needs maintenance. So similarly, the drip system also. So there is a regular cleanup of the filters, regular cleaning of the pipes, regular. There may be some still choking there, and you have to get that repairs. The fertigation is another important part on this, which is the the use of irrigation water and fertilizer together, and there are the different type of fertilizer. The equipments which are used in drip system to add this fertilizer gradually in the irrigation water, so that it can be added and can be irrigated. This is a kind of fertigation tank you can just see which is been installed, and this will help in dissolving the fertilizer in the irrigation water. There is a another part is called Venturi. This is another type of equipment which is helpful in fertigations. Another way is with the help of injector pumps, and they are also injecting the fertilizers. And then the fogger systems, which I have already shown you, that there is a foggers which are used for cooling down the polyhouses. And this was a discussion regarding the irrigation, the drip irrigation, the different components of drip irrigation, how to install a drip irrigation, the fertigation technologies, which are the different equipments which are used in fertigation, and which are helpful. So I hope these things are of usefulness to you. Thank you very much, students. Thank you.